Hello everyone. So today we will be seeing the nomenclature. The nomenclature of coordination compounds. Okay. So it's very easy. This is a short question for the board exam. The carbon chemistry, the organic chemistry nomenclature, and this also they will ask the nomenclature of coordination compound. So there are mainly two parts in naming the nomenclature in the coordination compounds. One is they will ask you write the formula for a compound, or by giving the formula they will give you name the compound. Just as in the organic chemistry what they are asking, the same way they will ask here also the coordination compounds. Okay, so there are certain rules to be followed here also for naming the nomenclature for the coordination compound. Okay, first we will see about how to write the formula for a coordination compound. Okay, now I just write a coordination compound just for name's sake. We will explain it one by one, but this is how a coordination compound looks like. The formula for a coordination compound looks like. You know, that is why we have studied the terminologies before. This is the coordination entity. The whole is the coordination sphere. This is the counter ion, which is the ionizable one. These are the secondary valencies or ligands. This is the central metal atom. Isn't it? So now we will see while writing a formula what all steps or what all rules you have to take care while writing a formula. Clear? Okay. First one is the central atom is listed first. So while writing the formula of a coordination compound, you have to write first the central atom. See, chromium. Clear? It is not the naming, but it is just the formula. Naming is entirely different. Okay, so formula must be Cr. So the central atom is listed first. Correct? Now what is the second one? The ligand is written in the alphabetical order. Alphabetical order means what we have studied in the carbon compound also, organic chemistry also. Alphabetical. For example, here it is amine and water is aqua. We will come to that. So amine AM, aqua AQ. So first it is written as amine AM, then it is AQ. Or if it is sorry, or if it is amine and chlorine, first amine A, then chlorine C. Or ethylene diamine, then first amine and then EN. So like that the ligands has to be written alphabetically. Or no, and the placement of ligand is not dependent on its charge. So if we are writing there are two ligands and the first ligand has got a -1, for example Cl -1, and the En is 0. So it is not necessary that the 0 must come first and then -1. No, all the ligands must be written in an alphabetical order. Whether it is more charged or less charged, that doesn't have a. Okay, so it is the ligands should be written in an alphabetical order. That is the second rule. The third rule is polydentate ligand is also written alphabetically. Polydentate ligand is also written alphabetically. Then when we take an example, we will come to know. Then fourth is the formula of entire coordination entity, whether it is charged or not, is enclosed in a square bracket. See, that is this much. Even if it is charged, for example, if 3Cl is not written, what will happen? It will possess a 3 minus charge, isn't it? If the 3Cl is not there, it will possess a charge here. But whether charge or no charge, the whole coordination entity must be in a square bracket. That is the next rule. Now what is the next rule? The ligands which are polyatomic. If the ligands are polyatomic, say NH3, it's a polyatomic. Then what? That ligand must be also, the formula should be in the parenthesis. Parenthesis means it's also bracket. It is like this, but you can have a bracket also. See, parenthesis means like this, but we will normally use bracket only, no problem. So if the ligand is a polyatomic, then that should be also in the bracket, not in square bracket, in parenthesis, curved brackets. But if Cl is there, you don't put bracket because only one. Isn't it? It is monoatomic. So you don't have to worry about that. But if it is polyatomic like NH3 or H2O 3 times, see H2O polyatomic, so that's also put in bracket, correct. So if it is a polyatomic also, the formula must be in a parenthesis, correct. Now again one more thing, the ligand abbreviation is using, as I told you while we are studying the ligand, we told about ethylene diamine, you can write EN, correct. So if that type of abbreviations you are using, UDTA, correct. So that type of abbreviation are using, then also you have to put parenthesis around that abbreviation. So these are the rules to be followed. So anyway, keep in mind the ligand should be put a parenthesis, that's all. If you have a custom of writing like that or habit of writing like that, whether if it is monatomic or polyatomic, just keep the ligands in what? Parenthesis, that's all. So there is no mistake happens. Now the fifth one is, there should be no space between the metal atom or the ligand in the whole coordination sphere. Or while you are writing the Cl3 also, you cannot have the space here, you just write Cl3, that's all. There is no space between the ligands and the metal atom in the whole coordination entity. So you can't put so many space between these two. Correct. So it is fully written. There is no space between. See, there is no space between the chromium, the metal and the ligands. Then, if there is a charge, as I told you, that if there is a charge like here, it is written as a superscript, not as a subscript. It is written as a superscript. First the number, charge number, and then the charge. Like 3 minus, not minus 3. It is written as 3 minus. Clear? It's very simple. Then at last, if there is charge or no charge, at last what? It should be a balanced formula. That means what? The charge on the cation must be balanced by the charge on the anion. Clear? So these are the rules to be followed for a formula. See, all the rules are here. That is, the central atom is listed first, the ligands then, it should be in alphabetical order, polydentate ligands is in the alphabetical order, then ligands, then the formula of the entire coordination must be in a square bracket. The ligands, polyatomic ligands are also in parenthesis. Then ligands abbreviations are using, that is also in parenthesis. There is no space between the central metal atom or ion or the ligands. Okay, then charge must be in a superscript like minus, not minus 3, but it is 3 minus. First the number and then the charge, and at last you have to ensure that the charge on the cation must be balanced by the charge on the anion. Is it clear? So these are the rules to be followed by writing a formula. Okay, now we will see what are the rules by which when you write the name or naming of a compound. Okay, now we will see how the naming, the rules of the naming, that's also very, very important. So we will see now what are the rules for naming. So in this I will just write the name as, see, triamine, then I will explain it. Okay, triamine, see, just see the spelling of amine, A-M-M-I-N-E, triamine, triaqua, okay, triaqua, okay, triamine, triaqua, chromium 3 chloride. So this is the name of this coordination compound. This is the name of this coordination compound. You see, first in the naming, the ligand name should come. While writing the formula, first you have to write the central metal atom. But while naming, the ligand must come in the name. Correct? Now what happens? One by one we will see the rule. The first rule is the cation is named first, and then the cation is named first in both positive and negatively charged coordination entity. So what do you mean by that? See, that I am taking this coordination compound. So all the coordination compound consists of a positive thing entity and a negative thing entity. Now first, what is it? Is a positive entity. Okay, so in this compound, the bracket is in the positive entity and this is in the chloride ion is the negative entity. Clear? So always while naming, you will say the positive entity first. Okay, positive entity first and then you will go for the negative entity. For example, see K4, Fe, Cn 6 times. In this, there are two things. This is positive and this is negative. This complex, the coordination entity is negative in this case, negative entity, and the potassium is in the positive entity. So here also you will first name, when you name it, you will take the positive entity. Potassium you will say, and then you will say this coordination entity, negative. Here, this you will say first and then you will say chloride. See? Triamine, triaqua, chromium, last is only chloride. First, this much is positive. Correct. So here also what you will say? You will say potassium. Okay. Potassium. Then hexacyanoferrate 3. I will explain how it comes. But still I just want to make a differentiation between the positive and negative entity. So here also we are writing the positive entity first, potassium. Sorry, not this coordination entity. So in all the coordination compounds, there is a positive and a negative entity. First is positive and then you will write the negative. So first you will write the positive, you will name the positive entity. Correct? Whether the coordination entity is minus or plus, whatever is written in the first, that is the positive. That means the example is this. In here the coordination entity is a positive entity, but in this case negative entity. Clear? The metal atom comes in the negative entity. Here the metal atom comes in the positive entity. Clear? That is the first rule. Now the second rule is, what is it? The ligands are named in the alphabetical order before the central metal ion. Okay? Central metal atom എഴുതുന്നതിന് മുമ്പ് തന്നെ എന്തെഴുതണം? Ligands alphabetical order എഴുതുക. A കഴിഞ്ഞ് B കഴിഞ്ഞ് C കഴിഞ്ഞ് അങ്ങനെ എഴുതുക. Correct? Okay. So then the third is it's very important. The names of the anionic ligands end in O. Very important. What did it say? The names of the anionic ligands. What do you mean anionic ligands? Anionic ligands means Cl minus. Anion is chloride. So you cannot write chloride in coordination compound. You have to delete this E or erase the E and put O. That is chlorido. Chlorido. Or some people write chloro. But chlorido is more correct. Because chloride ion, you said chlorido. Then cyano, Cn minus. See? Cyano. So it should end in O. That means the negative ions, that if the ligands are negative ions, then that must end in the letter O. That is a very important rule. Correct? Then what is that? That of neutral and cationic ligands. Now if the ligand is neutral, or if by somehow if the ligand is positive also, then the same name can be applied to it. Correct? But there is exceptions for that in neutral molecule. For example, amine. See, amine is NH3. NH3 is ammonium or amine. There, the spelling is not A-I-A-M-I-N-E, but the spelling is A-M-M-I-N-E. That is one exception. Second exception, for water, they will call it as aqua. For water, you cannot write it as water, but you should write it as aqua. Clear? Aqua. Okay. Now, then amine, aqua, then like in neutral molecules. Negative ligands means that is chlorido, cyano, nitrito. Nitrito, see, NO2. NO2 is a minus ligand. So, nitrate. So, it is nitrito, ends in O. See? So, when we write so many practice, so many compounds, it is very easy for you. Don't worry. Okay, we will do that. Okay, that is the third. Okay, so then amine, then NH3, that is amine, then carbonyl, CO. CO is carbonyl. CO is carbonyl. Okay, carbonyl, then NO. NO is nitrosyl. So these are the exceptions for the neutral molecule. Like NH3 is amine, water is aqua, then CO is carbonyl, then NO is nitrosyl. So if NO is comes, you have to put nitrosyl. If CO is comes, you have to write carbonyl. Correct? Okay. Now the fourth is, you have to prefix mono, di, tri, etc. That is why NH3 3 times, you can put triamine. H2O 3 times, triaqua. If it is 2, di. Clear? So the prefixes mono, di, tri, etc. must be there according to the ligands. How many ligands are there in each cases? The prefixes mono, di, tri, etc. are there. Clear? Now then when the name of the ligand includes a numerical prefix, see, if the ligand itself contains a numerical, for example, it's very important, listen carefully what I said. If the ligand itself contains a numerical, chlorine means there is no numerical, so dichloro. Cyano means there is no numerical in that ligand, so dicyano or monocyano or whatever, tricyano or etc. Correct. But what is in the case of ethylene diamine? There is a di coming in ethylene, right? En. Ethylene diamine means ethylene diamine. So in the name itself, in the ligand name itself, there is a di. So in that case, very, very important, in that case, if En is twice, see, in that case, if this ligand is twice, so what is this ligand? Ethylene diamine. So di is there. So that twice. So in that case, the 2 you have to write it as bis. What is it? Bis. Or if it is thrice, tris. Correct. If it is 4, it is tetrakis. See? Bis, tris or tetrakis. So you can say bis ethylene diamine like that. The ligand will go like that. Bis bracket En. No problem. You don't want to abbreviation, don't want to elaborate. You just write bis En, which means that the En is again a numerical is there. Correct. So that is a very important rule. Correct. Okay. Now then bis, tris, tetrakis, etc. is there. Correct. Now the fifth one is the oxidation state of this metal in the cation, anion, etc. is yesterday we told you oxidation number is always written in Roman numeral and in parenthesis. See, Roman numeral and in parenthesis. That means chromium, it is 3. Okay. Now we will see how it got 3. Okay, very important. Just listen carefully. How you have written the chromium as 3. See, once more I will write Cr, NH3 thrice, H2O thrice. Okay. Then the whole bracket coordination entity Cl3. The counter ion is chloride. Okay. Adile chromium in the oxidation number engane kandupidikkunnu okay. You have to know the valency. This neutral ആണ് 0. NH3 neutral ആണ്. En neutral ആണ്. പിന്നെ En neutral ആണ്. പിന്നെ Cn -1 ആണ്. NO -1 ആണ്. Okay, so നമ്മൾ പഠിക്കുമ്പോൾ അത് മനസ്സിലാക്കി പോകണം. So അപ്പോൾ നോക്കിയേ ഇത് 3 × 0 0 3 × 0 0. നമ്മൾ അവസാനത്തെ ഒരു എണ്ണം പറഞ്ഞ എന്താണ്? The balanced, the positive charge is balanced by the negative charge. അപ്പോൾ ഈ കൗണ്ടർ അയോൺ എന്താണ്? -3 ആണ്. ശരിയല്ലേ? ക്ലോറിൻ 3 ഉണ്ട്. സോ ക്ലോറിൻ ഈസ് -1. സോ -1 × 3 ഈസ് -3. അപ്പോൾ ഇത് എന്തായിരിക്കണം? ക്രോമിയം must be +3. എന്നാലല്ലേ 0 ആവാൻ പറ്റത്തുള്ളൂ. മനസ്സിലായോ? അതായത് ഇവിടുത്തെ മാത്രമല്ല നോക്കേണ്ടത്, നമ്മൾ ആ കംപ്ലീറ്റ് കോർഡിനേഷൻ കോമ്പൗണ്ടിൻ്റെ അതാ പറഞ്ഞത്. ഇൻ ഓവറോൾ എന്താണ്? ദ നെഗറ്റീവ് ചാർജ് ഈസ് ബാലൻസ്ഡ് ബൈ ദ പോസിറ്റീവ് ചാർജ്. ശരിയല്ലേ? സോ ഇങ്ങനെയാണ് നമ്മൾ ഓക്സിഡേഷൻ. അപ്പോൾ ക്രോമിയം എത്രയാണ് ഓക്സിഡേഷൻ സ്റ്റേറ്റ്? +3. അതാണ് റോമൻ ന്യൂമറിൽ നമ്മൾ ഇട്ടേക്കുന്നത്. ക്ലിയർ? So this is the next, and the last important rule in this is, okay, if the complex ion is a cation, very important. നമ്മൾ പറഞ്ഞു രണ്ട് എൻറ്റിറ്റി ഉണ്ട്. There is a positive entity and there is a negative entity. നമ്മൾ ആദ്യം എഴുതുന്ന ഏതാണ്? പോസിറ്റീവ് എൻറ്റിറ്റി തന്നെയാണ് നമ്മൾ പറയുന്നത്, അല്ലേ? അപ്പൊ നമുക്ക് നോക്കാം, നമുക്ക് രണ്ട് എക്സാമ്പിൾ തന്നെ എടുത്ത് നോക്കാം. നോക്കിയേ, ഈ എക്സാമ്പിളില് നമ്മൾ ഇപ്പോൾ എടുത്ത എക്സാമ്പിളില് നോക്കിയേ, ഈ കാറ്റയോൺ അല്ല, നമ്മുടെ മെറ്റൽ ആറ്റം കാറ്റയോൺ ആണോ ആനയോൺ ആണോ? ഫോർ എക്സാമ്പിൾ ക്രോമിയം NH3 thrice, H2O thrice, then NT and Cl3. ഇതിൽ നോക്കിയേ, ആദ്യം നമ്മൾ എഴുതുന്നത് നമുക്ക് രണ്ടായിട്ട് തന്നെ എഴുതണം. സോ ദിസ് ഈസ് നമ്മൾ ആദ്യം പോസിറ്റീവ് എഴുതുന്നത്. പോസിറ്റീവ് എൻറ്റിറ്റി ആണ്, ഇത് നെഗറ്റീവ് എൻറ്റിറ്റി ആണ്. ഇങ്ങനെ എഴുതരുത്, ചുമ്മാ നിങ്ങൾക്ക് മനസ്സിലാക്കാൻ വേണ്ടിയാണ് കേട്ടോ. സോ പോസിറ്റീവ്. അപ്പൊ നമ്മുടെ ഈ മെറ്റൽ ആറ്റം എവിടെയാണ്? പോസിറ്റീവ് എൻറ്റിറ്റിയാണ് കിടക്കുന്നത്, ശരിയല്ലേ? അതേസമയം ഈ എക്സാമ്പിളില് K4 FeCN6 ടൈംസ് ഇങ്ങനെ ഒരു കോമ്പൗണ്ട് ഉണ്ടെങ്കിൽ നമ്മൾ എന്ത് ചെയ്യും? ഇത് രണ്ടായിട്ട് ഡിവൈഡ് ചെയ്താൽ ദിസ് ഈസ് ദ പോസിറ്റീവ് എൻറ്റിറ്റി ആൻഡ് ദിസ് ഈസ് ദ നെഗറ്റീവ് എൻറ്റിറ്റി. നോക്കി, ഇപ്പൊ മനസ്സിലായോ ആ വ്യത്യാസം? ദിസ് ഈസ് ദ പോസിറ്റീവ് എൻറ്റിറ്റി ആൻഡ് ദിസ് ഈസ് ദ നെഗറ്റീവ് എൻറ്റിറ്റി. ഇനി നമ്മുടെ ഇഫ് ദ കോംപ്ലക്സ് അയോൺ ഈസ് എ കാറ്റയോൺ, ഇത് നമ്മുടെ കോംപ്ലക്സ് ഏതാണ്? ഇതിനകത്ത് ഇതാണ് നമ്മുടെ കോംപ്ലക്സ്. ഇതിലേതാണ് കോംപ്ലക്സ്? ഇതാണ് നമ്മുടെ കോംപ്ലക്സ്. ബ്രാക്കറ്റിൽ എഴുതുന്നതാണ് എപ്പോഴും നമ്മുടെ കോംപ്ലക്സ്. അങ്ങനെയാണെങ്കിൽ ഇഫ് ദ കോംപ്ലക്സ് അയോൺ ഈസ് എ കാറ്റയോൺ, നമ്മുടെ പോസിറ്റീവ് എൻറ്റിറ്റിയിലാണ് വരുന്നതെങ്കിൽ ദ സെൻട്രൽ മെറ്റൽ ആറ്റം അല്ലെങ്കിൽ അയോൺ, ദ സെൻട്രൽ ഈ ആറ്റം സെൻട്രൽ മെറ്റൽ ആറ്റം, അതിന്റെ പേര് അങ്ങനെ തന്നെ എഴുതുക. ദാറ്റ് മീൻസ് ഇവിടെ ക്രോമിയം തന്നെ നമ്മൾ എഴുതിയത് ക്രോമിയം 3 അങ്ങനല്ലേ എഴുതിയത്? ബിക്കോസ് അപ്പൊ നമുക്കറിയാം അതൊരു പോസിറ്റീവ് ആദ്യം കിടക്കുകയാണ്. കോംപ്ലക്സ് കാറ്റയോൺ ആണ്. കോംപ്ലക്സിലെ മെറ്റൽ ആറ്റം കാറ്റയോൺ ആണ്, അതായത് പ്ലസ് സൈഡിലാണ് കിടക്കുന്നത്, പോസിറ്റീവ് എൻറ്റിറ്റിയിലാണ് കിടക്കുന്നത്. Correct? So if the complex ion is a cation, then the name of the cation is written as such: chromium, platinum, nickel, iron, silver, etc. Correct? The atom is an anion. Anion എന്ന് പറഞ്ഞാൽ എങ്ങനെയായിരിക്കും? നെഗറ്റീവ് എൻറ്റിറ്റിയിലാണ് കോംപ്ലക്സ് എങ്കിൽ, നോക്കിയേ, ഈ നെഗറ്റീവ് എൻറ്റിറ്റിയിലാണ്. അപ്പൊ അയൺ എന്താണ്? നെഗറ്റീവ് ആണ്. അങ്ങനെ നെഗറ്റീവ് എൻറ്റിറ്റിയിലാണ് നമ്മുടെ കോംപ്ലക്സ് എങ്കിൽ, കോംപ്ലക്സ് നെഗറ്റീവ് ആണെങ്കിൽ, അല്ലെങ്കിൽ ഈ അയോൺ നമ്മുടെ സെൻട്രൽ മെറ്റൽ ആറ്റം ആനയോൺ ആണെങ്കിൽ, ശരിയല്ലേ? ഇത് നെഗറ്റീവ് പറയുമ്പോൾ ആനയോൺ അല്ലേ? ആനയോൺ ആണെങ്കിൽ എന്ത് ചെയ്യും? ആ നെയിമിംഗ് ഓഫ് ദ മെറ്റൽ ഷുഡ് എൻഡ് ഇൻ AET എന്ന് പറഞ്ഞാൽ എന്താ? ക്രോമിയം will be chromate, zinc will be zincate. So it should all end in the AET. Iron എന്താണ്? Ionite പറയാൻ പറ്റത്തില്ല. So it is written as ferrate. Silverate പറയാൻ പറ്റത്തില്ല. So it is written as argentate. Clear? So this is how the name goes. So these are the rules for naming the coordination compound. Clear? So we will do some of examples now. With 2 or 3 examples we will do. Okay. So okay, now moving on to the examples. The first example is, first we will name it. Correct? First we will name it. 2-3 times I will show you. Okay. The second is CO. See, second is CO. NH3 4 times. NH3 4 times, H2O 1 time, and Cl, the whole bracket closed, Cl2. Okay, this is the first example. ഒന്ന് രണ്ടെണ്ണം ചെയ്യാം എന്നിട്ട് ബാക്കി നിങ്ങൾ ചെയ്തോളൂ. നമുക്ക് ചെയ്യാം. ഇതെങ്ങനെ ചെയ്യും നോക്കി. ഇതെങ്ങനെ ചെയ്യും? അതായത് ഫസ്റ്റ് നമ്മൾ എന്താ പറഞ്ഞേ, നമ്മൾ നെയിം എഴുതുമ്പം ആദ്യം ഏത് എഴുതണം? ആദ്യം ലിഗാൻഡ്സ് എഴുതണം. അപ്പൊ എന്താണ്? ടെട്രാ ആണോ? ടെട്രാ amine, tetramine, isn't it? Tetramine. So it is tetramine, A-M-M-I-N-E. Listen, A-M-M. Tetramine. Tetramine. Then what is H2O? Aqua. Then what is Cl? Cl is minus. So it is chlorido, isn't it? Tetramine, tetramine, aqua, chlorido. Then comes cobalt, isn't it? Cobalt. Okay. Then oxidation number. Oxidation number is what? Listen carefully. This is -1. This is 0. This is 0. Correct? Okay. So what is this? This is -2. Chlorine is -1. So 2 chlorine -2. So this altogether is -3. So cobalt is +3. Correct? So now Roman +3 chloride. See? This is how the naming goes. Clear? So it is tetramine, aqua, chlorido, cobalt 3 chloride. Is it clear? Now one more I will say. K2. Okay, second one. K2. Then Zn. Zn. OH 4 times. OH 4 times. First you have to see this is the positive entity. This is the negative entity. So our metal atom comes in the anion. So what will be that? Zincate. Okay. But we should write the positive entity first. What is it? Potassium. Isn't it? Potassium. Potassium. Then potassium. Then again this entity how we will write? The same as this. That is tetra. Tetra. OH is minus ion. So hydroxo. Isn't it? Hydroxyl. So it is hydroxo zincate. Isn't it? Zincate. Now what is the valency? How you will have valency? K. This is -1. So 4 into -1, that is -4. K2 is +2. Now what is zinc? Zinc will be +2. So -4 and +4, 0. Isn't it? So it will be zincate 2. See? This is how you write the name. Clear? You write the name. Okay. Now one more example we will write. This is very easy. That's what. Very easy. One more example we will write. See, in this example, AgNH3 twice. AgNH3 twice. This is one. And again AgCN twice. See, AgCN twice. Now, if this type of coordination compound comes, what the same rule is applying, but 2 in the complex form. So this is positive and this is negative. So this is positive. So what you will write? You will write what you will write? You will write diamine, isn't it? A-M-M-I-N-E. See that word? A-M-M, not A-M. Diamine. Since it is positive, you can write it as silver. Okay, silver. Okay, now this silver has got 1 because silver cannot be more than 1. Always the valency of silver is 1. Okay, now what is this? This is again what? Dicyano. This is minus entity. So it is dicyanoargentate 1. See? This is how the name goes. That is diamine silver 1 and dicyanoargentate. R is small letter. Dicyanoargentate. Dicyano, because cyano is a negative, so it should end in O. Dicyanoargentate 1. Clear? So this is how it goes. Why? Because silver is 1. Why? Because this is -2. So it must be this +1. This is 0. So this is +1. That is how +1 comes for both the silver. So this is how the naming goes. Now we will see one ulta. That means we will have the name. You have to write the formula. Okay. That also we will try one or two. That is, the name will be given. We have to write the formula. Correct. Now the first is write dichlorido. Okay. The naming is dichlorido. Okay. Dichlorido bis. Okay. Dichlorido bis ethylene diamine cobalt 3. So this is the naming, and now we have to write it in a formula. The naming is given and then the question is asked, write the formula for this compound. So how will you write? Okay, write formula. What happens? First in the formula we have the cobalt, the metal, isn't it? So first we will have cobalt. Okay, cobalt. Then what you will have? Then you will have dichlorido, that is Cl2. Okay, dichlorido bis. Bis means ethylene diamine twice. Isn't it? Ethylene diamine twice. Okay, ethylene diamine twice. Now the whole bracket. Now the point is, we have to check for the oxidation number. Okay, what is oxidation number? See, En is 0. Chloride is -1, so -1 into 2, -2. Correct? Now listen very carefully. It's very important. This we will look -2 അല്ലേ ഉള്ളൂ. അപ്പോൾ നമ്മൾ എന്ത് ചെയ്യും? ഇത് 0 ആണ്. അപ്പോൾ നമ്മൾ +2 ഇടും. പക്ഷേ in this you have given it is +3. It is +3. തന്നിട്ടുണ്ട് +3 ആണെന്ന്. അതാണ് ഇതിന്റെ ഒരു ഗുണം. അപ്പോൾ എന്ത് വരണം? -3 വരണ്ടേ? -2 അല്ലേ ഉള്ളൂ. അപ്പോൾ ഇവിടെ എന്ത് വരും? There is a charge here as -1. Okay? As a charge here as a -1. Cobalt 3 അല്ലേ പറഞ്ഞേക്കുന്നത്? Cobalt 3 പറയുമ്പോൾ CO Cl2 En sorry 2 3 അല്ലേ +1. Okay? +1 അല്ലേ വരുന്നത്? കാരണം എന്താ? That is x is equal to -2, sorry, x -2 is equal to +1. അപ്പോൾ x is equal to 3. നല്ല വരിക. അപ്പോൾ ഇവിടെ +1 വന്നാലേ നമുക്ക് എന്ത് വരാൻ പറ്റത്തുള്ളൂ? ഇവിടെ നമുക്ക് തന്നിരിക്കുന്ന 3 ഇവിടെ വരാൻ പറ്റത്തുള്ളൂ. So in that case this is a charged complex. See, this is a charged complex. കിട്ടിയോ? Okay. One more we will write. We will write tetracarbonyl. Okay. Next is tetracarbonyl nickel 0. Tetracarbonyl nickel 0. How will you write? First you have to write the metal atom. Then tetracarbonyl. Carbonyl is CO 4 times. Nickel valency is 0. Why? Because carbonyl is 0. So that's okay. So the formula will be NiCO 4 times. Clear? You want one more? If you want one more, we will write. Right? Okay. Then write mercury tetracyano. Okay. For one more. Mercury tetracyano. Mercury thiocyaneto. Okay, sorry. Mercury tetrathiocyanato. Okay, cyanato. So this is minus. Cyanato. Cobaltate 3. So how will you write the same? See, you know, ഇതിനകത്തൊരു പ്രത്യേകതയുണ്ട്. Mercury tetrathiocyanato cobaltate 3 എന്ന് പറഞ്ഞാൽ ഇത് ഇത്രയും ഒരു കോംപ്ലക്സ് ആണ്. മെർക്കുറി വേറെയാണ്. അപ്പോൾ നമുക്കറിയാം മെർക്കുറി പോസിറ്റീവ് സൈഡിൽ വരും. ഓക്കെ, എന്നിട്ടാണ് നമ്മുടെ കോംപ്ലക്സ്. അതുകൊണ്ടാണ് അത് പൊട്ടാഷ്യം അങ്ങനെ പറഞ്ഞില്ലേ ഇവിടെ. അതുപോലെ മെർക്കുറി tetrathiocyanato. Thiocyaneto means SCN. Isn't it? SCN. First cobalt, isn't it? ആദ്യം cobalt അല്ലേ എഴുതുക. First cobalt, then SCN 4 times, okay, then thrice. Okay, 3 vedam okay, SCN minus 1 aanu, minus 1 minus 4 out, Hg plus 1 out, cobalt is plus 3, correct. So Hg, CO, SCN 4 times. So this is how you write the names as well as the formula. Now what you will do is, there is in-text example questions, question number 3 and question number 4. Okay, so that as a homework, and I think one more exercise is there, that is question in-text question 9.1, 9.2. 9.1 and 9.2 homework. Question 3 and question 4 also homework. So just you have a practice on this naming as well as the formula. If you are given name, how to write the formula. If you are given formula, how to write the name. Okay. So once you are done with that, we will next move on to the bonding in coordination compound. Because next in your textbook there is an isomerism, stereoisomerism as well as structural isomerism. You know stereoisomerism is optical and geometrical, so that is a deleted portion. Now you are straight away going into the bonding in the coordination compound. 2 theories you will have to study, the VB theory and the crystal field theory. So that we will see in the next session. So till then, thank you.